This is slide number 12 and I am your presenter Asloob Mutassar. Field just after an object. So the field just after an object is equal to the field just before the object multiplied by the amplitude and phase distribution at the object. So if the field before an object is known, we can calculate the field very easily after the object, provided the amplitude and phase information at the object plane are known. So just the input field at the object plane multiplied by the amplitude and phase distribution at the object plane will give you the field just after the object. Now the lens as a phase transformer. If our lens is free of dust particles, moistures, or any manufacturing defect, then we shall say that our crystal clear lens is just only a phase transformer. That is, the amplitude of the incident beam through the lens will remain unaffected and only the phase distribution of the incident wave will be changed. And later on we shall see that how the phase information is changed there. The modeling of the field incident on the object. Now we want to present the modeling of the plane wave which can be incident on an object. Half cycle of a plane wave with selected wave fronts and one D profile are shown on the top as in this figure. So you can see that these planes which we have drawn with our limited size, but these are actually infinite in size in both dimensions. And all these wavefronts, the wavefronts are very large, but we have shown only discrete values of the wavefronts. And all these wavefronts are parallel to each other and they are propagating in the direction of a propagation vector k. So our first plane is at 0 phase. Another phase which has the highest intensity is at pi by 2, and another phase at the half cycle is at a location of pi with the value equal to with the value equal to 0. So you can say that we have generated this one using a sine function. So sine function is 0 initially, and then you know that at the value of pi by 2 the sine peaks up, giving a value of, for example, 1, and then sine goes to 0 at the value of pi. So you can see that we have generated these plane waves using a sine functions. And at each point, you see that the phase value at each of these plane values will change. For example, we have shown only 3 phase values there: the phase value 0, the phase value of pi by 2, and the phase value of t. And we have shown just only the half cycle. And at the top we have shown one-dimensional profile. For example, one-dimensional sinusoidal functions, you can say. We have shown actually 2 points P0 and P1 at this point. So actually in the figure these are the 2P, but the lower one is P0 and the upper one is P, and we can join these 2 points and you know that the vector joining the point P0 to P1 will be a vector which is perpendicular to the vector K. Now the wavefronts are infinitely large, but only selected portions are shown. The propagation vector k can be written as k is equal to kx into unit vector I plus ky into unit vector j plus kz into unit vector k. And writing kx, ky and kz in terms of the vector k, we have k cos of alpha into unit vector I plus k cos of alpha beta into unit vector j plus k cos of gamma into unit vector k. And alpha, beta and gamma are the angles which the propagation vector k makes with the x-axis, y-axis and z-axis of the coordinate axis. Now the vector joining the points P0 to P is given by P0 to P is equal to x minus x0 into unit vector I plus y minus y0 into unit vector j plus z minus z0 into unit vector k. So we have written this P0 to P, P0 to P vector. P0 is a fixed point. The lower point is actually P0 and the upper point is actually P. So the upper point P can take any value. So its coordinates are x, y, z, whereas the lower point which is P0, its coordinates are fixed, which is x0, y0 and z0. So we have written a vector joining P0 to P P, and the vector is x minus x naught into unit vector I plus y minus y naught into unit vector j plus z minus z naught into unit vector k. Now you know that this vector, which is P naught P, is perpendicular to the vector k. We shall have a further discussion in the next slide. So this is the end of slide number 12.